Okay, today we're going to be graphing inequalities. This is one of my favorite sections. I love graphing inequalities. And graphing inequalities is not going to be very much different than graphing the equalities we did in Unit 4. We're still going to start with our y-intercept, which is our constant at the end, which I'm going to plot my point at 1, 2, 3, 4. So there's our beginning point, and then I have my slope, which is actually the -1. Or the negative part, and then I can make that into a fraction by putting it over 1. So my slope is going down 1 to the right 1. Down 1 to the right 1. That pattern repeats for the points on my line. And I'm going to get these points up here. Now, with y is greater than or equal to, you'll notice if it's greater than or equal to or less than or equal to, we're going to use a solid line. Okay, so just like the equality, that line is going to be a solid line through those 2 points, and that means that every point on this line is a solution to the inequality. Now, one difference is that there are lots of different solutions to this inequality. So I need to shade one side of the line or I need to shade the other. And to make that determination, we're going to use a test point. Most people use the test point 0, 0. If 0, 0 is not on your line, feel free to use it. So I'm going to plug that in. So I'm going to get 0 is greater than or equal to -0 plus 4. And that will simplify down to 0 is greater than or equal to 4. And I'm going to check and see if it's true or not. Is 0 greater than or equal to 4? No. Okay, it's not true. So what that means is I need to shade the other side of the line. Okay, so here was my test point. This is not a solution. That means that none of the points on this side of the line is a solution. So that means that the points on the other side of the line are solutions. So here I am, I'm shading in all of the solutions. That means any point that I pick in this shaded region will work in this inequality. So if I pick the point 2, 5, 2, 5 would be a solution. I would get a true statement. Calculator. Your calculator will also graph these, which is really neat. So we're going to type in the equation. Y is equal to -x plus 4. Now, before you hit graph, though, come all the way over to the left side. Okay, you see the line here? You can change the line. So this is just a normal line. If I hit enter, that gives me a thicker line. If I hit enter again, this is the greater than. It will shade in the sign greater than. So since our equation is greater than, I'm going to go ahead and leave that section here. And you can see it's a triangle in the upper right hand corner. That's the greater than symbol. So then when I press graph, it graphs the line that I have, and then you can see it shaded above just like mine. So these calculators will graph inequalities for you as well. I'm going to move my calculator over so I can go to number 2. Okay, again, we're going to start out with our y-intercept. In this case, our y-intercept is -3, so I'm going to come down 1, 2, 3. And my slope is -2. And I can change that to a fraction by putting it -2 over 1. So that means I'm going to go down 2 to the right 1 and start my point. And then I'm going to go in the opposite direction. So instead of going down 2, I'm going to go up 2. Instead of right, I'm going to go left 1. And I'm going to repeat that pattern to form my line. Okay, this time I have a less than sign. So whenever you see a less than or greater than sign, it's going to be a dashed line. Okay, that's going to be similar to our open dot that we had on our number line. Okay, and what that means is that all of the solutions go up to this line, but they don't include them. So all of these points that I just plotted are not solutions to the inequality. Now again, we will have to use a test point. So test point, again, I can use 0, 0. And I'm going to plug that in. So I get 0 is less than -2 times 0 minus 3. and I get 0 is less than negative 3 because this equals 0. Is 0 less than negative 3? No, that's false. So that means I need to shade the other side. Shade the other side. Okay, so my point here was on my right side. It's not a solution, so that means I need to shade the left side of the line. So that means everything that I'm shading here is a solution to the inequality. So all of these points work and give me a true statement in the inequality. Again, going back to our calculator, I can type in negative 2x minus 3. And again, I need to go all the way back to that left side. And I'm going to hit enter again. And now my box changes to the bottom left hand. That's the less than sign. It's going to shade everything less than y. And I'm going to hit enter. And you can see that it graphs the same graph and shades it less than. So based on my sign, it said y was less than. I used the less than symbol. Alright, number 3. Points on a solid line, they are solutions. Those are points that can be used to make the inequality true. So again, we're going to start at our y-intercept. That's going to be up at 3. And my slope is 2. And I can rewrite that as 2 over 1. So that means the pattern between my points is going to be up 2 to the right 1. I'm going to repeat that pattern by going the opposite direction. And I have a less than or equal to sign, so it will be a solid line. That means all of these points are solutions to the inequalities. That's why it's a solid line. Okay, now I need to use my test point. Test point 0, 0 is good again. So I get 0 is less than or equal to 2 times 0 plus 3. 0 is less than or equal to 3. Is 0 less than or equal to 3? Yes. So that is a true statement. Here's my test point here. So that means I need to shade this side. Okay, since my test point is here at 0, 0 and it did give me a true statement, then I shade that side of the equation. So that means all of these points that I'm shading in here are solutions to the inequality. All of these points will make that inequality true. Oh, calculator. So I've got y equals 2x plus 3, and my inequality is less than or equal to, so I am going to keep that little bottom left-hand triangle. And my graphs do match. Does shade it less than. Okay, number 4. Points on a dashed line are not solutions. Okay, they go up to those points, but they don't include them. Okay, here we have an equation that is in standard form, and we usually graph our equations in slope-intercept form. So our first step into solving for y is to get rid of x. So I'm going to subtract x from both sides, and I get y is less than, and I'm going to move my x term to the front, negative x plus 6. Okay, so there's our equation we're going to graph. So that means I'm starting up at 6. So 1, 2, 3, 4, 5, 6. And I'm going down 1 to the right 1. And I'm going to repeat that pattern. Okay, and points on a dashed line, since it is less than, it's going to be a dashed line between them. That means it goes up to those points but doesn't include it. Now I do need my test point again. I'm going to use 0, 0. So I'm going to put in 0 for y. Actually, it'd probably be easier to go back to the original, because then that would be 0 plus 0 is less than 6. Is 0 less than 6? Yes, it is. So if 0 is less than 6, then I shade that side. Here's 0, 0. So that means I'm shading on this side of the line. So all of these points that I'm shading in right now are solutions to the inequality. So any one of these points you can pick and it would be a true statement. Okay, calculator. Even when we have a standard form, we still need to put in the slope-intercept form. So I'm going to change that to negative x plus 6. My sign is less than, so my symbol here will be the less than. So I'm going to keep that bottom left triangle and press graph, and I can see that my graphs do match. Okay, number 5. This is in standard form, so again I'm going to have to get it in slope-intercept form, so I'm going to subtract 5x from both sides, and I get negative 10y is less than, I'm going to move my x term first, negative 5x plus 15, then I'm going to divide by negative 10, and if you'll remember from the last lesson, anytime you multiply or divide by a negative number, you must flip the inequality sign. Okay, that was in the last lesson, so I am dividing by negative 10, so that means I'm going to have to flip that sign. So my y is going to be now greater than negative 5 over negative 10 simplifies to 1/2 x, and negative 15 over 10 becomes negative 3 over 2. And you can have that as a decimal or not. I'm going to leave it as a fraction. So graphing wise, I need to be at negative 3/2, and negative 3/2 is negative 1/2. So I'm actually going to start right here in the middle between 1 and 2. And I'm going to go up 1 to the right 2, which is going to still put me in the middle of that point. Up 1 to the right 2, and I'm going to repeat that pattern. And I'm going to go in the opposite direction here to continue my points. Okay, I do notice that I have a less than sign. So a less than sign means I have a dotted line. And my test point is again going to be 0, 0. You can continue to use the test point, but I'm going to use my inequality sign. My y is greater than the line. So here's my line, here's my y-intercept. So if I'm going greater than y, greater would be above the line here. If I were to be less than, then I would be below the line. So instead of using a test point, I'm going to be using the inequality sign, and it says y is greater than the line. So here are my y's that are bigger than the line. So I know I'm going to be shading in above the line because my y values are going to be greater than what I've graphed. And so that's going to be my equation, or my graph with the inequality. So using my calculator, I'm going to go back to y equals. I'm going to clear that out, and I'm going to type in 1/2 x minus 3 over 2. And I'm going to go back all the way over to the right, and it says greater than. So I'm going to click enter until I get my top right hand symbol. That's the greater than, and I'm going to press graph, and you can see that it graphed to the same side of the line that I did. Number 6. This is not in standard form, but it's not in slope-intercept form yet either because of that -6. So really the only step I need to perform here is to get y by itself by dividing by -6. So I'm going to divide everything by -6. And again, I'm dividing by a negative number. So that means I need to switch or flip my sign around. So that gives me y is less than or equal to, and I'm also going to take my x term and put it first. So -18 divided by -6 is positive 3x, and then 12 divided by -6 is -2. So my equation becomes y is less than or equal to 3x minus 2. So I'm going to start to graph that. I'm going to go up to 2. Oh, not up to 2. Actually, I need to go down to -2. Got to watch those signs. And I'm going to go up 3 to the right 1. Up 3 to the right 1. And I'm going to reverse the order, going down 3 to the left 1. Now, since this is greater than or less than or equal to, that does mean I'm going to have a solid line through my points, which means those points are included as part of the solution. And again, I'm going to use my inequality sign. Y's are less than or equal to the line. So here's my line. So that means my y's are less than the line. Well, here's my y-intercept. So greater than is above, less than is below. So that means all of these points below my line are going to be solutions. So I'm going to shade in that side. With the calculator. Clear it, and I have 3x minus 2, and I'm going to have to go arrow over, and this time my symbol is less than, so I've got the thick line here, the greater than symbol there, and the less than symbol here. And now I'm going to press graph, and I get the same graph as I had before. Alright. Okay, number 7. This is our horizontal line that goes through 2, so and it's less than, so it's going to be a dotted line. So we're fairly consistent with graphing the horizontal and vertical lines. So I'm going to draw a dotted line through 2. And then shading wise, it says y is greater than 2. So if I come over here to my y-intercept at 2 and y is greater than my line, then I'm going to be shading above. So my shading is going to be above my line. Again, you can use the calculator on this one as well. You can go to y equals. I'm going to clear that out, and I just can type in 2. And going back over, y is greater than, so I'm going to hit enter until I get my top right hand symbol and press graph, and I get the same graph. Y is greater than 2. Number 8, x is less than or equal to -3. So I'm going to come over to my x-axis at -3, and it's going to be a solid line because it's less than or equal to. I'm going to draw a solid line at -3 for x, and it says x is less than or equal to -3. So here's my x, and I want where my x's are less than -3. Well, less than is to my left, so that means all of these points on my left side are going to be shaded in. So that represents all of the solutions where x is less than -3. We can't use the calculator to graph that. Okay, does this point work as a solution? Well, let's find out. Plug the point into the inequality and check to see if the solution is true. So this is just evaluating. So if -2 is my x coordinate and 4 is my y coordinate, I'm just going to plug those in. So y is 4. That's less than 3 times -2 minus 2. We're going to simplify that. 4 is less than -6 minus 2. 4 is less than negative 8? Is 4 less than negative 8? And that's no. So since it's no, then that represents that this point is not a solution to the inequality. Number 10. Again, this is my x, this is my y. I'm going to plug in the points. Excuse me. 6 is greater than or equal to 1/2 times 2 plus 5. 6 is greater than or equal to 1/2 times 2 is 1 plus 5. 6 is greater than or equal to 6. Is 6 greater than or equal to 6? Yes. So that means that 2, 6 is a solution to this inequality. Number 11, 0, 0. Well, 0 plus 0 is greater than negative 9. Is 0 greater than negative 9? Yes. So that is a solution. 0, 0 is a solution. 12. We get 14 minus 9 is greater than or equal to 8. 14 minus 9 is 5. Is 5 greater than or equal to 8? No. So 14, 9 is not a solution. 13. I have 5 times negative 3 plus 2 times 6 is less than or equal to 8. That gives me negative 15 plus 12 is less than or equal to 8. Negative 3 is less than or equal to 8. Yes, it is. That's a true statement, so that means negative 3, 6 is a solution. Number 14. I'm going to have 4 times 6 minus 3 times 8 and see if that's greater than or equal to negative 5. I get 24 minus 24. Is that greater than or equal to negative 5? 0 is greater than or equal to negative 5. Yes, it is, and that makes it a solution. Recap. What did we learn today? We learned how to graph inequalities. We learned how to shade, and you can use a test point. And we determined if a point was a solution.